The objective of this experiment is to determine the relationship between head loss due to friction and velocity for the flow of water through smooth-bore pipes.
Today, we're diving into the fascinating world of fluid mechanics, specifically what happens when water travels through a pipe.
That's right, Hazik. It's not just about getting from point A to point B, but every time fluid flows, it hits a hidden enemy, which is frictional losses.
Exactly.
But
whether a pipe is perfectly smooth or rough, fluid molecules rub against the pipe wall and rub against each other. This creates friction, causing a drop in energy known as head loss or HF.
But wait, how do we calculate this loss? Let's bring up the heavy hitter, which is the Darcy-Weisbach equation.
Here it is. To find head loss, we look at the length of the pipe divided by its diameter and multiplied by the kinetic energy. But notice that tricky little F at the front. That's our pipe friction factor.
And to solve for F, we first need to know how the fluid is behaving. Is it calm or is it chaotic? For that, we need to calculate the famous Reynolds number.
This magic number depends on the fluid density, its velocity, the pipe diameter, and its viscosity.
Now, back in the day, a scientist named Osborne Reynolds realized something amazing, which is fluid flows generally falls into two completely different regimes. Let's look at the graph.
First, at low velocities, we have laminar flow. Think of it like a smooth, neat layers of fluid sliding past each other. Here, head loss is linearly proportional to velocity. If you double the speed, you double the loss. It's a nice, predictable straight line.
But turn up the speed, and everything changes. At higher velocity, we crash into turbulent flow, where the fluid starts whirling and mixing like crazy. Suddenly, head loss skyrockets because it's now proportional to velocity raised to a power, which is h directly proportional to u to the power of n.
And check out the messy middle part, the transition phase. There's no definite relationship between head loss and velocity here. The fluid is literally deciding whether to be calm or crazy.
To make this easier to analyze, scientists plot this exact data on a log-to-log scales. Let's look at figure 3.2.
The beauty of logarithm. By taking the log of both sides, that crazy turbulent curve turns into a crisp straight line with a steep slope.
Look closely at the transition zone here. It marks distinct threshold, the lower critical velocity, where laminar flow starts to break down, and the higher critical velocity where full-blown turbulent flow completely takes over.
So, whether you are designing water supply network or just looking at the plumbing in your house, understanding Reynolds number and head loss changes everything.
Thanks for watching. Drop your fluid dynamic question in the comment below. And we'll see you in the next lab session. Thank you guys. Bye.
Assalamualaikum and good day everyone. My name is Zahir Afifi bin Shamsul, AA 250103, and I'll be explaining the procedure for the losses in pipe experiment. Now, let's go through the procedure of this experiment. First, the fluid friction and manometer apparatus was switched on to start the system. Next, the inlet and outlet valve were opened to allow water to flow through the test section. In this experiment, two pipe diameters were tested, which were 7.5 millimeters and 10 millimeters. To determine the head loss, a stopwatch was used. Once the water started flowing, the stopwatch was started simultaneously. The water was then collected until the volume reached 5 liters. When the 5 liters mark was reached, the stopwatch was stopped immediately. After that, the head loss reading was taken from the manometer as quickly as possible to ensure accurate measurement. The measured data, including the time taken, pipe diameter, volume of water collected, and head loss value were then recorded in the data collection table. The same procedure was repeated for the other pipe diameter. And finally, the remaining parameters were calculated using the recorded data and the equation provided in the laboratory manual. That concludes the procedure for the losses in pipe experiment. Thank you.